So today we're talking about the ionic bond. Okay, the ionic bond is a bond formed by transfer of electrons, usually from a metal to a non-metal. So it's the way a metal combines with a non-metal by donating its electrons to the non-metal. Hi, I'm Wisdom Richman. Welcome to Wisdom Analysis. This channel is all about making chemistry easy and fun. So please subscribe if this is your first time on my channel. Okay, so today I'll be talking about the ionic bond. I'll be talking about the definition, the examples of ionic compounds, and the properties of these ionic compounds. Okay, now let's go straight into the video. Like I said earlier, ionic bond is the way a metal combines with a non-metal by transferring electrons to the non-metal. So the metals are the donors and the non-metals are the acceptors. Okay, but generally in chemical bonding, the purpose of this bonding is to form a stable octet or a stable duplet. A stable octet is having 8 electrons in its outermost shell. That is having 8 in its outermost shell. Okay, let's say there's a policy that everyone must have not more than 8 pair of shoes or less than 8 pair of shoes. So it must be 8, not more than 8, not less than 8. And I have 9 pair of shoes and you only have 7. So you are not in alignment with the policy and I'm not in alignment with the policy. So I am going to give my extra pair of shoes to you. So you are going to be 8 pair of shoes. So I am going to also have the 8 pair of shoes. So that is our bonding. That's our friendship because I gave you a pair of shoes to make you 8. So that's how this works. In sodium chloride, your popular table salt, you see that sodium has 1 electron in its outermost shell. So for it to have 8 electrons remaining, it has to give out that 1 electron from the outermost shell. But look at chlorine over there. Chlorine needs just 1 to complete 8 electrons. So it has to take that 1 electron from sodium. It has to accept that 1 electron from sodium to make 8 electrons. So sodium donates that 1 electron and sodium has just 8 in its outermost shell because the third shell does not have any electron again but it has given it out. So it is 8 in the outermost shell, and then for chlorine it accepts that electron to also have 8 in its outermost shell. But ionic bonding does not only go by stable octets, there is also a stable duplet. Okay, when drawing atomic shells, you see that the first shell can hold up to 2 electrons. Yeah, so the stable duplet has to do with just that first shell because the first shell can only hold up to 2 electrons. The highest it can hold is 2 electrons. So you see, when lithium combines with hydrogen, you see that lithium, after that first shell having 2 electrons, it has 1 extra on its second shell. But when you see hydrogen just has 1 in its first shell. So hydrogen needs to complete a stable duplet by having 2 electrons in the outermost shell. So you see that 1 electron, extra electron in lithium will move over to the hydrogen. So hydrogen will have 2 electrons in its atomic shell now, and lithium also have 2 electrons in its atomic shell. So stable octet is having 8 electrons in its outermost shell, while stable duplet is having 2 electrons in the outermost shell. But stable duplet for small atoms like lithium, hydrogen, let's say boron, and so on. So most compounds deal with stable octets. Now let's give other examples. So chemical compounds combine stable duplet and the stable octet phenomenon. Okay, now let's check this. Let's say we have sodium hydride. Now in sodium hydride, NaH is a combination between sodium and hydrogen. So sodium has 1 electron in its outermost shell and hydrogen has 1 electron in its shell too. So hydrogen is still in that first shell. So what it needs is not a stable octet, it is a stable duplet. So it needs 1 more electron to complete a stable duplet, while sodium needs to give out that 1 electron to be a stable octet. So it gives it to the hydrogen and hydrogen becomes a stable duplet while sodium becomes a stable octet. But I've only explained by giving 1 electron. There are cases whereby atoms do not just give 1 electron, they give 2 at once or maybe even 3. let's say calcium oxide is between the calcium and the oxygen. You can see that calcium have 2 electrons in its outermost shell, while oxygen only has 6. So for oxygen to complete a stable octet, it needs 2 more electrons, while for calcium to complete a stable octet, it needs to give out that 2 electrons. So it gives it out to oxygen, and oxygen becomes a stable octet. So you can see this is how this ionic bond is formed. Well, let me give a question. Go and analyze calcium chloride, that is CaCl2, and leave it in the comment section what you found out. The electrons it donated and how did the 2 chlorine atoms combine with the calcium. So now I've given the definition and also examples. So now let's go straight into the properties of these ionic compounds. Ionic compounds are solids at room temperature and do not vaporize easily. Yeah, you can testify if you heat yourself at home. Well, that should be done under adult supervision. And the second property of ionic compounds is that they dissolve in water and other polar solvents. So they dissolve in water and other polar solvents. The third property of ionic compound is that in molten or in solution form, they are good conductors of electricity, so they are used as electrolytes. And the fourth property of ionic compounds is that they do not dissolve in non-polar solvents like benzene. The fifth property of ionic compounds is that they have high melting and boiling points. While the sixth property of ionic compounds is that they are not made up of molecules. Did I just say that? Yes. They are not made up of molecules, but they are made up of 3-dimensional crystal lattices of opposite charge ions. Yes, they are not made up of molecules. So you can see that when sodium donates that 1 electron to chlorine, if an atom donates 1 electron, it turns to an ion of a positive charge 1. So you can see that sodium is donating that 1 electron will have a +1, which is just a plus. And chlorine accepting that 1 electron will become a negative. So when they combine, they do not just combine as atoms, but the donating and accepting of electrons make them ions. So the atom, that is chlorine, accepting the electron becomes a negative because it is just 1 electron it accepted. While the sodium, giving out that 1 electron, it becomes sodium with a plus there. So let's go straight to the calcium oxide. You can analyze the rest on your own. So calcium donating that 2 electrons to oxygen becomes a +2, while oxygen accepting that 2 electron becomes a -2. Yeah, I know you understood that. But if you are still worried about how these ions are formed, I made a full video on how these ions are formed, linked in the description of this video. Okay, we have come to the end of this video. Please like, it helps me out on YouTube, and please subscribe to my YouTube channel. It helps me grow my channel, and I'll see you in my further videos. Okay, in my next video I'll be talking about the covalent bond.